Okay, let's look at question number 14, part A, which is the differentiation and graphing question. So if x is given, x cannot be equal to minus 4. We have to find the derivative, right? So apply the quotient rule and get the derivative. So x plus 4 whole thing squared. Then we keep x plus 4 squared here. Differentiate this one, the numerator term. Rather than using product rule, just expand it and do it. It's easier, no? Just the power rule. Then you get what? 2x minus 4 minus x into x minus 4 times derivative of the denominator, which is 2 into x plus 4 times 1. Right now let's simplify and take the common terms out. You can take 2 and x plus 4 out from the numerator. Then you are left with x plus 4 times x minus 2 from here minus x minus 4 is left, and the denominator is x plus 4 to the fourth power. Right, so now we can cancel 1x plus 4 and the denominator part is done. Now let's simplify the numerator to the required expression. Two is there, x squared 4x minus 2x minus 8 minus x squared plus 4x, whole thing over x plus 4 cube. So this one cancel this one. 8x 6x minus 8 inside. So f dash x is 2 times 6x minus 8 x plus 4 cube. Take a 2 out, so 4 times 3x minus 4 over x plus 4 cube. Yes, that's what we want. Right, so that part is done. Derivative is done. Hence find the intervals on which fx is increasing and decreasing, right? And sketch the graph indicating asymptotes, turning points, points of intersection with x and y, right? So let's find the increasing decreasing intervals. That depends on what? The derivative sign. And to find the intervals, let's find the points where the derivative is 0 and derivative does not exist. So those are the critical values or critical numbers. Derivative does not exist when the numerator is 0. So x equals, sorry, derivative is 0 when numerator is 0. So then x equals 4 over 3. Derivative does not exist when denominator is equal to 0. So x equals minus 4. Right. And turning point can only occur at a stationary point. So this point is not a turning point. From here you get what? Vertical asymptote. You will have a vertical asymptote there. Right. So we'll break the number line using these two values, minus 4 and 4 over 3. So now figure out the derivative sign in each interval using test values. So you have two brackets. What happens in the numerator and the denominator? Let's take test value as minus 10. So numerator is minus, denominator is minus cube, so still minus. So minus over minus is plus. So this is increasing. Derivative positive means gradient positive, so increasing. Between minus 4 and 4 over 3, let's use 0. Then negative, numerator is negative, denominator is 4 cube, 4 positive, minus, so positive is minus, so decreasing in this interval. Then after 3 over 4, let's take 5 as the test value, so positive, positive, so increasing in this interval, right? So then let's decide the nature of the stationary point, the turning point. So our turning point is this one, so decreasing then increasing, so local mean at x equals 4 over 3. So let's find the y value. So to find the y value, I have to substitute to the function, so this one. So let's find the y value. Y equals 4 over 3, 4 over 3 minus 4, then 4 over 3 plus 4 cube, no, sorry, not cube, square. So what do we have? 4 over 3 minus 8 over 3, no, 4 over 3 minus 4 means minus 8 over 3, 4 over 3 minus 8 over 3. In the denominator we have 12, 16 over 3 times 16 over 3. So the 3's cancel, minus 32 over 16 over 16. So minus 1 over 8, right? So the y value is minus 1 over 8. So that's our minimum, local minimum point, right? So that is done, right? So let's finish the increasing decreasing intervals. So increasing intervals, there's 2. Let's write them. Increasing, you have negative infinity to negative 4 and union 4 over 3 to infinity. And decreasing, you have in between minus 4 to 4 over 3. Turning point is 4 over 3 minus 1 over 8, right? So then what else do we need to draw the graph? So now we have to draw the graph. Asymptotes, turning points we found, x-axis and y-axis intersection points. So x-intercepts and y-intercepts. So let's find the x-intercept and y-intercept. Y-intercept is the easy one. No, substitute x equals 0. So sub x equals 0, the numerator is 0. No? So y-intercept is 0. So y-intercept 0. X-intercept, you have to solve this function fx equals 0. So then the numerator has to be equal to 0. So 2 x-intercept, 0 and 4. 0 and 4 are the x-intercepts, right? So then this is done, this is done. So what we are left with is to find the asymptotes, right? Okay, so let's continue. So now we need to find what? Vertical asymptotes and horizontal asymptotes. So fx equals, let's go back to the function x minus 4 over x plus 4 square. Right. So vertical asymptotes are what? For a rational function, the shortcut is what? Points where the denominator becomes 0. So here the vertical asymptote is x equals minus 4. Right. Then the horizontal asymptotes you find by doing what? Finding the limit as x approaches infinity or negative infinity. So then it just depends on the leading terms of your function. So x squared minus 4x, x squared plus 8x plus 16. So all the other terms will become 0 when you apply the limit. Only the leading terms will affect it. So what do you get? 1. If you divide the leading terms, you get 1. No? So there's your horizontal asymptote, which is y equals 1. You can show the limit also. It's not much work. Just divide everything by x squared. Then apply the limit to each term. So all of these terms become 0. No? So 1 over 1 equals 1. So that is why horizontal asymptote is y equals 1. So now everything is found. So we'll draw the diagram. Right. Only asymptotes, turning points, and intersection points we need to mark. Right. So then, right. We'll draw it now. So what points? We'll first mark the asymptotes. X equals minus 4 and y equals 1. X equals minus 4. 1, 2, 3, 4. X equals minus 4, which is the vertical asymptote. Y equals 1 is the horizontal asymptote. Right. Then I just use these arrows to connect the sections. It is easy when you use it like this. Right. So then what else do we need to mark? Asymptotes are done. Let's mark the intercept 0, 4, 0. So 0 and at 4. Right. So right. So there's our x intercepts. Y intercepts are marked. Let's mark the turning point next. 4 over 3 comma minus 1 over 8. So around here 4 over 3 minus 1 over 8, very close to the y-axis. Right, somewhere roughly we'll say this is minus 1 over 8. This is 4 over 3. Right. So we have what? This turning point is local mean. So local mean. So let's put a small valley shape here. So we know this is a local mean. Right. Right. So now let's use the increasing decreasing intervals to get the graph. So first we'll look at from where? What happens from negative infinity to minus 4? Increasing. Negative infinity to minus 4 increasing. So which two arrows do I need to connect? These two or these two? the down arrows gives you a decreasing shape, no, so that doesn't work. We want increasing shape, no, so the two arrows here is the ones you have to connect, right? So then you get the first shape, right? Then erase these two arrows, we don't need them because that section is done, no? Now the next section is from -4 to where? -4 to -4/3. So no, 4/3, this one. So from this asymptote up to here, 4/3, right? So what is happening in that section? That is decreasing, that is this section, decreasing, -4 to 4/3 decreasing, and you have to go through 0 also. So which arrows can I connect? Which arrow and this one should I connect? If I connect this arrow to this one, you get an increasing shape, no? So it's wrong. You want decreasing shape, so this arrow to this one. So that's how you connect this section. So like that. Right, so there's right. So then the final section is where with this section is done. So 4/3 to infinity, so increasing shape, and you have to cross this point, x-intercept at 4. So then, and it has to come towards the right. So let me make this more clearer that this point is a minimum. So our minimum point. And crosses at 4. And comes towards that asymptote. So that's the shape of the curve. So that's done. Then what are you supposed to do? Right, second derivative is given to be that, and we have to show 4, 0 is the point of inflection. Okay. Right, this point. So yeah, we can't get this same shape without changing the concavity, no, at 4. Yes, so yes, so we'll show that using the second derivative test. So f double dash is what? F double dash is -24 x minus 4 over x plus 4 to the 4th power. Right, so then like you do for the first derivative test, mark the points where the second derivative is 0 and does not exist. So -4 and 4. And the only point where the inflection point can occur is when x equals 4. -4, the value is not in the domain, so it won't be a inflection point. So right, now check the second derivative sign. It only depends on what? Numerator. Denominator is always positive, no? So put some test values and see. -10, 0, and +10. So second derivative is when -10 minus positive. -4 to 4, 0, no? again minus minus positive, right? Again minus minus positive, then 10 minus positive minus. So concaving up, concaving up, concaving down. So concavity changes at 4. So this is an inflection point, 4 comma 0, because the concavity changes at x equals 4. Concavity changes, therefore 4 comma 0 is a inflection point, right? So that is done. What else do you need, right? That is done. Deduce the graph of this for x less than minus 8, for x less than minus 8. Okay, so what is this? Right, right. The graph we drew is what? Fx x. We have to use that to deduce x minus 4, x plus 4 square. It's 4 x plus 4 squared. We drew it for all x values other than minus 4, right? Right, then the graph we want to draw now is what? Deduce the graph of x plus 4 x plus 4 x plus 8 squared for x values less than minus 8, for x values less than minus 8, right? So look, you can write this new function using function f. Everything has been shifted to the left by 4 points. F of x plus 4 is what? Check. X plus 4, x plus 4 minus 4, x plus 4 plus 4 square. So that is what? That is y, no? So what do you need to do? This graph we already have, no? Function f we already have. F of x plus 4 means what? F of x plus 4 is a transformation. Shift 4 units left. Everything has to shift 4 units left. You have to shift the graph of fx 4 units to the left. So what will happen then? Shape is the same. Everything shifts 4 units to the left. And we only want to draw which section? X less than minus 8 section. So now look, everything shifts to the left by 4 units, no? So then this asymptote at minus 4 shifts where? It shifts to minus 8. And we only want to draw the section from x less than minus 8. So this is the only section you have to draw. You can ignore this whole thing because they want us to draw from x less than minus 8. So everything shifts to the left by 4 units. So this asymptote will shift to minus 8. So then you only need to draw everything left of that. So this is the graph shape. Your asymptote is now at minus 8. The horizontal asymptote doesn't change. This shifts left, no? Nothing in vertical direction changes. Then there stays the same. So this is 1. X equals minus 8 is the new asymptote, and you only want to draw the graph for x less than minus 8. So then only this section. So just draw this section. Shapes remains the same. So this is the answer for the last part. Right. This is a new type of question. So practice that type. So you need to use transformations for that. Right. So then we'll do part B.